Hello and welcome once again. So as you can see, the question that we have now is expressing the following numbers in the form of P by Q. How are we going to do that? You have learned this concept in class 7, how to convert a recurring decimal into a fraction. Anyways, let's just go through it once again. So taking the first question 0.3, and you can see a bar on top of 3, which means that the digit 3 is repeating again and again. So let's write this question 0.3 and a bar on top, which means or 0.3333 as many times as you want to write. So if you have to convert this into a fraction, now we know that a recurring decimal is a rational number, which means it can be converted back to a P by Q, that is the fraction form. So in this we use the technique where we form two equations, remember. So we can say let x is equal to 0.3333, and we can name it as the first equation. So always remember, when you form the first equation, try to have the repeating digit just after the decimal place, the repeating digit. If there is a non-repeating digit after the decimal place, try to remove it or try to shift it before the decimal place. We'll look at an example. So here let's assume that this is the first equation, and now in order to get the second equation, you try to see how many repeating digits are there. So here we have one repeating digit 3333. So in order to bring 1 3 this side of the decimal, we can multiply a 10. So let's multiply 10 on both sides. So multiplying 10 on both sides. So if you multiply 10 on both sides, it will 10 into x, 10x, and if you multiply 10 into 0.3, you will get 3.3333 ... So you can name this as the second equation. As soon as you get the first equation and the second equation, if you recall what we did, we subtracted the first equation from the second equation. So here you write subtract equation 1 from 2. So whatever is on the left side you subtract, and whatever is on the right side you subtract. So 10x minus x is equal to 3.3333 ... minus 0.3333 ... Now if you observe carefully, 10x minus x will give you 9x, whereas this side the decimal places will be cancelled. The 333 infinity times subtracted by 333 infinity times will result in 0. So ultimately we have the number on the left side, that is 3 minus 0, which is 3. So here we can represent this as x is equal to 3 by 9. So 3 1s are 3 3s are. So x is equal to 1 by 3. So here we have successfully represented or converted 0.3333, the repeating decimal, as 1 by 3. So this will be your answer. Clear? Next question. Now let's take a question where we have a non-repeating digit, and after that we have the repeating decimals digits in the decimal places. So here let's take 0.4 and 7, which is a repeating digit after that. So fourth number 0.47 and a bar on top of 7, or we can write it as 0.477777 ... right? Now let's name it as the first equation, let x equals to 0.4777 dot 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 dot. Now I told you something earlier, that don't take the non-repeating digit in this equation as the first equation, don't count it. Try to bring this 4 this side in order to get the first equation. So here we can multiply both sides by 10 in order to bring this 4 this side. So 10 into x will give you 10x, and 10 into 0.477 will give you 4.777, and another 7 we can write this. Now you see that this repeating digit has come just after the decimal place. So whenever you have this kind of expression, then you consider this as the first equation. So we can consider this as the first equation. Now let's go for the second equation. In the second equation, what are we going to see? What is the repeating digit, whether it is a 1 digit or a 2 digit. So here we see 7 is repeating, so it's a 1 repeating digit. So it means to bring it this side of the decimal, we need to multiply what? 10. So again we'll write multiplying both sides by 10. So you have to use your understanding as to what you have to multiply. If there were 2 repeating digits, so in order to bring both of the repeating digit this side, you will have to multiply 100. So the same goes for 3 repeating digits. I hope you understand that. So let's multiply both sides by 10. So here 10 into 10 will give you 100x equals to 10 into 4.777 will give you 47.777 dot 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 dot. That 7 came this side. So here we have this as your equation 2. Now you know the rule, subtract equation 1 from equation 2. So write down, subtract 1 from 2. So 100x minus 10x this side, and on this side we have 47.777 dot 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 minus 4.777 dot 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 dot. Now see, I'll tell you why we did not take this first expression as the first equation. If you had taken it and solved it accordingly, you would have got the same answer what we are about to get right now. Here, for the convenience of directly getting the fractional form, we have not taken the first expression as the first equation. We are taking second one. Why? Here you can see in this form, decimal places will get cancelled easily. What if we had taken the first expression as the first equation? Here you see 4 is here, which is a non-repeating digit, means it is just after this decimal place. So when we subtract, this 4 will be here and we will get the answer in decimals here. So in order to remove that decimal part, we have taken the second expression by multiplying 10 as the first equation. So now when we subtract, we will get 47 minus 4. That is what we have to do. All the decimal places will get cancelled. So 47 minus 4 gives you 43. So you see clearly the decimal places have gone, and 100x minus 10x will give you 90x, which is equal to, x is equal to 43 by 90. Now can we simplify it further? No. So leave it as it is. So this will be your expression of 0.4 and a 0.47 and a bar on top of 7, which is equal to 43 by 90. This will be your answer. Is that clear?